This problem is a good example of how we can use our rotational dynamics to solve a problem. So if you look at the problem, we have some information that's given to us talking about this bicycle wheel that is spinning at a certain angular velocity, and we have friction that's causing the wheel to slow down and then come to a stop in a certain amount of time. We're also given the moment of inertia in the wheel about its axle, and we're trying to find the magnitude of the frictional torque. So if I just write down everything I know that the wheel initially is spinning with an angular velocity of 0.72 revolutions per second. I know that it's going to come to a stop, so I know that my final angular velocity is going to be 0 revolutions per second, and it's going to take a time of 12 seconds in order to cause the wheel to slow down and come to a stop. So the first thing I know is that my angular acceleration is equal to my change in my angular velocity divided by the time. So if I plug in what I have here, I know that I have a final velocity of 0 revolutions per second. I have an initial velocity of 0.72 revolutions per second, and then I have a time of 12 seconds. And so if I just calculate this, I get, basically it's negative 0.72 divided by 12, so I have negative 0.06 revolutions per second squared. So that's going to be my angular acceleration. Now what we're going to do is we're going to figure out the amount of torque that's being done on this wheel. And the way we can do that is we know our angular acceleration equals the net torque that we have divided by the moment of inertia. So we know the angular acceleration of this wheel is negative 0.06 revolutions per second squared. We don't know the net amount of torque. We know the moment of inertia is 0.3 kilograms meters squared. So if I multiply both sides by 0.3, I have a net torque of negative 0.018, and that's going to be meters newtons. That's my answer. That's how I can find the amount of torque. So that's very similar to problems we did earlier on in the year where we had to use kinematics. In this case, we're looking at a rotational kinematics to find our angular acceleration. And then at that point, we just use our Newton's second law, in this case, Newton's second law of rotational motion, in order to figure out our net torque that we have on the object.